Hi everyone, I am Sri Devi, Professor, Department of Electronics and Communication Engineering, Rogini College of Engineering and Technology. In this video lecture, we are going to learn about what is a multiplexer and demultiplexer. And at the end of this course, the learners can be able to understand the concepts of multiplexer and demultiplexer. Initially, you have to know the purpose of using a multiplexer in a combination circuit. So multiplexer is a type of combination circuit that accepts multiple inputs of data but provides only a single output. And just reverse of demultiplexer. Demultiplexer refers to a type of combination circuit that accepts just a single input but directs it through multiple outputs. So this is the difference between multiplexer and demultiplexer. Basically, uh, it is a combination circuit, that means with no memory, that is called as a combination circuit. So both multiplexer and demultiplexer are the types of combination digital circuits widely used in many large scale digital systems. The major difference between the multiplexer and demultiplexer is their ability to accept the multiple input signals and a single input signal respectively. Here, this is the symbolic representation of a mux. In this symbolic representation, we have yes, it is like a digital switch. It has multiple input sources, and here 2 power n is the input sources in mux, and 1 is the output destination. Mux types are 2 to 1 select line, and 4 to 1 select lines, 8 to 1 mux, and 16 to 1 mux. So here 2 to 1 means here number of inputs here is 1 and number of selective lines is 1. 4 to 1 means number of input line is 4 and number of selective lines is 2 power 2. So here this 2 is selective lines, and 8 to 1 means 2 power 3 is 8. So here 8 to 1 multiplexer, we are having 3 selective lines. Similarly, we are having different types of multiplexers, and here this is the multiplexer application of a multiplexer and in different sources. So MP3 player, docking station, and laptop sound card, digital satellite, digital cable TV. Here are the uses of our applications of multiple lines, which accepts different types of selective lines. From the selective lines, the selector will select a single line. So for example, in this circuit, here in this multiplexer section, we are having D0, D1, D2, D3 are the lines, and finally Y is the selective line. Among this D0 to D3, any one selective line is selected. For example, two selective lines means 0 0 0 1 1 0 1 1. 0 0 represents 0, 0 1 represents 1, 1 0 represents 2, and 1 1 represents 3. So here in this case, 0 0 is for MP3 and 0 1 for laptop, and 1 0 for satellite, and 1 1 for cable TV. So different types of multiplexers are 4 to 1 multiplexer. We said here 4 input lines, and it will accept a single data selector. So 4 means it is noted as D0, D1, D2, D3. So D0 means here we are having two selective lines, let it be A and B. Here this NAND gate NOT gate is connected and it is enabled. D0 is selected means the output is D0, the final answer should be 0 and 0. D1 is selected means 0 1, and D2 is selected means 1 0, and D3 is selected means that is 1 1. And next is the concept of demultiplexer. It is also known as demux. A demux is a digital switch which is considered as input source, and it produces a output which number of destinations, just reverse of that of multiplexer. In multiplexer, the output is just a single output, data will be selected, but here we are having number of outputs here. So for example, demultiplexer types are here 1 to 2 demultiplexer, 1 to 4 demux, 1 to 8 demux, and 1 to 16 demux. These all are having different types of selective lenses, 2, 3, 4, etc. So this is the basic demux circuit. The given is the block diagram of demux. Here n is the number of selective lines. Here 1 represents the input source, that is 1, and 2 power n is the output. And typical applications of demux are just single source to selector and multiple applications: BW laser printer, fax machine, color inkjet printer, and pen plotter. These all are the selective lines choosing demux applications. So typical application of demultiplexers are like this, and one example of demux is 1 to 4 demux. So only one input is given and 4 output is obtained. So this is called as 1 to 4 demux. X is the input and D0, D1, D2, D3, D4 are the output. So basically the demux is the combination circuit which performs the inverse operation of a multiplexer. And now we have the multiplexer and demux. IC diagram is this one. So these all are the different applications of mux and demux. Hope this session is understandable. Thank you for watching. Thank you. And finally we have one quiz question here. Why multiplexer and demultiplexer is needed in a combination circuit? The answer is multiplexers and demultiplexers are the circuits that are used in digital communication systems to encode or decode data between devices and different networks. This is the major application or major principle of operation of a multiplexer. Thank you.